Okay, a 3D graphic shows a Rubik's Cube on display stand. The drawing on the right shows the incomplete projections of the object. Complete the elevation of the cube. Okay, that's step one. So step one here is you have a cube. We've done this already, so we should be able to label them all. So we can call them, this corner is 1, this corner will be 2, 3, 4, 5, 6. Back corner here then, we call this 7, then the back corner can be 8. Okay, so all we need to do, like we did in all the other questions, line down at 45 degrees. We brought our piece of saw 5 across and up. Okay, so that would be 5. Okay, 6 then across, bring 6 up. This can be 6. Okay, this can be 4. So if you take it, you bring all your points across, label them, okay, it'll make more sense of it straight away. It's going to be 1. So 3 then. So 3 and 5 are in line with each other, so 3 is at the back there. 3 and 5, you can see there 2 and 6. So 2 and 6. We have 4 at the top, 1 here. So we then down this corner here, we're going to have 7. Okay, so if you label everything, some people don't like doing it. If you label it, you're going to have more chance of finding all your points. And we can see then 8 is on this corner here. Okay, so if we have located our points in 2 views, we're going to bring them across and find them in our 3rd view. Okay, so for example, we bring 7. I'm going to bring 7 up lightly and bring 7 across, and that's going to give us 0.7. Okay, so all we need to do is do that for all our points. So we'll pick 3. So there's 3 and 5 there. That's the height. So that's going to be 0.3. This is going to be 0.5. Okay, so we have them in 2 views, and then we'll find them in the 3rd view. So there's 3, 5, 7. We bring 4 across, bring 4 up. It's on the same line there, 7. So that's going to be 4. Okay, so 4, 5, 7, and 3. We have all that area there, 4, 5, 7 and 3. So we know that when we look in, we're going to see this here. So we can join them back together. So we get all the rest of our points in. So 8 is on the ground line, 8 is in the center, so we know 8 is going to be here. We have 2 and 6 on this height here. We know 2 and 6 are on them lines there, so that's going to be 6, that's going to be 2. So the only thing we're missing then is 1, so 1 is on the center line. We have 1 here, so we need to bring 1 across. So that's going to be 1. So now we have 1, 2, 3, 4, 5, 6, 7, 8. So we have all our points. All we need to do then is decide what we're going to see and what's going to be hidden detail. Okay, so first of all, our hidden detail will be any edge at the back that we can't see, and anything we will see will be solid. So if we're looking in from the side view, we're getting this. So obviously from our front view, we'll be looking in here. So we will see this edge here. So 3 goes to 4. One goes to 4. 1 goes to 2. 2 goes to 3. So that's our first edge we're going to see. Okay, we know then 2 goes to 8. So we're going to see that, but the rest then, because it's sitting in to the stand, is hidden detail. So it's probably start taking shape now. 6 goes to 1, 5 goes to 4. If you find it hard to follow, label your points in the 3D image as well. Okay, so 6 goes to 8. 6 down to 8, and then hidden detail. Okay, so that's our cube, but that's our 4 sides that we can see, or sorry, 3 sides that we can see, and we have edges at the back that we can't see, so it's going to be hidden detail. So we know 8 goes to 7, hidden detail. And we know 7, we go to 3, that's also hidden detail because at the back. And we know then 5 goes to 7, that's hidden detail. So that's our finished elevation, and our end view and plan was there. So what we need to figure out now is we have to determine the diameter of the smallest possible sphere that would contain the cube. So they haven't said circumscribe or inscribe, but the sphere has to contain the cube. So obviously the cube goes inside the sphere. So remember from our previous examples, if we have a cube, if we join the diagonals, so from one corner all the way over to the other corner, that's going to be the diameter of our cube, of our sphere. Okay, so if we bisect it, it'll be the radius of our sphere. Okay, so for anyone that doesn't remember that, okay, just make a note of it. So if we join any of these, so for example, if we join 8 to 4, so it's like this, if this was 8 and this was 4, we're joining 8 to 4. If we join 7 to 1, okay, that would give us the true length. So when we look at our cube standing, we know 8 to 4 is going to give us our diameter, because we're joining the diagonals. So we need to find the center point of our sphere. So we get our compass, and we're going to bisect it to get our radius. Once it's bisected, where it cuts through here is going to give us our center point. So that's our center point. Okay, so our distance from here to here is going to be our radius. Okay, so all we need to do is get our compass on the center point to the outermost point of the cube there. And we need to spin our sphere. Try and keep pressure on it. Just take your time. So we have a radius, keep that radius on our compass. We have our center point, so all we need to do is bring our center point across into all our views. So our center point there is going to be on that point here. Get our sphere, or sorry, get our radius for our sphere. And we're going to spin it. Okay, it should touch at the top point and the bottom point. So it's actually not touching 4 there. So that's just an inaccuracy in my drawing. So if it's not touching, rub it out. Make sure it's fixed. You can bring down our center point then from our end view. So we know it's on here, bring it across, have that center point here, locate them into 2 views to find them in this view. So the plan, we have our radius, so we're going to spin our radius again to complete the sphere, if it lets me do it. Okay, so that's the solution to that question.